Here we have the series of -1 to the n plus 1 dividing by the third root of n. And we want to show that this alternating series converges absolutely. And here's the definition of conditional convergence. And so what it says is that a series is conditionally convergent if this series converges. And then if we put absolute value around this and it diverges, then we say that the series converges. And so first we have to show, that this right here converges. And then second, we have to show that if we put absolute value around this, that expression, and this diverges. And so that's what the definition of conditional convergence is. First, we have to show that the series here, the alternating series here, converges. And then if we put absolute value around here, it diverges. And so now we will show that this right here converges. And so note is an alternating series. And recall that for an alternating series, and we want to show that it converges, we have to show two conditions. The limit of a sub n is equal to 0, and that a sub n is greater than or equal to a sub n plus 1. So this series right here, this can be rewritten as this. And so for this series, we have a sub n is equal to 1 divided by the third root of n. And right here we can see that the limit of a sub n which is the limit of this, is 1 divided by infinity, which is 0. So this is condition number 1, and then we have to show also that a sub n is greater than a sub n plus 1. And so we have a sub n is this, and so a sub n plus 1, then just replace the n with n plus 1. And so we have this is less than that. And now we do the reciprocal, and this will be greater than this. So anytime we do the reciprocal, we have to reverse the inequality sign. And so we have shown two things. The limit of a sub n is equal to 0, and that a sub n is greater than a sub n plus 1. And therefore, this alternating series converges. By alternating series test. Now we need to show, and then that's the first part. So first we have shown that this converges, and then now we need to show that this diverges. And this just we put absolute value around this, it just takes the negative one away. So once again, if we put absolute value around this expression right here, then the negative one becomes the positive one. And then we can rewrite this. This is the third root of n to the first. So that's the same. And so this is the, so this is n to the 1/3. And this is a p series with p equal to 1/3. And so since we have 0, p is between a 0 and 1, then this series right here diverges by p-series test. Okay. One more time, the p-series test says that if p is between 0 and 1, including 1, then the series diverges. But if p is greater than 1, then the series converges. And so, in summary, we've shown two things. We have shown that this series converges, but and then we have also shown that if we put absolute value around this part right here, then it diverges. And therefore, we say that the series right here converges conditionally. So that's what it means to be for a series to converge conditionally. And so that's what we have to show when we want to show that the series converges conditionally.